I'm Alex, a CTO at Streaming Fest. I'm also a pianist and some sort of data scientist and software architect. I'm the father of 9 beautiful children, and I love designing and crafting software, which I've done since I was 12. And I met Satoshi in 2013, and since then I've gathered all that blockchain knowledge, and today I'm CTO at Streaming Fest, a Montreal-based company who's one of the core developer teams of the Graph. And our goal and mission is to make the world of open data with that shared intelligence layer in a low-cost and high-performance package, technology to do these things. What I mean by shared intelligence layer is that crowdsourced knowledge from the people, groups, turned into code. And when data is more open, creativity sparks from all the ends of the world, and often from places we wouldn't expect. So we joined the Graph after a stunt we made. I don't know if you guys know subgraphs. Raise your hand if you know subgraphs. Oh, okay, cool. You guys are good. And we take a very popular yet very slow to sync subgraph, and it took two months to do. We made it in 10 hours. How? Using the tech I'm going to present today. And since then, the Graph has decided to make these fundamental pieces of technology the underpinning of its high performance and multi-chain strategy. So these are Firehose and Substreams. Firehose is a means to get data out of blockchains and extract it, and Substreams is a massively parallelized transformation engine over Firehose data. Let's start with that one here. Firehose, here. At Streaming Fast, we've been thinking hard of all these indexing problems, from first principles, and we needed a robust extraction layer, get to the data we needed to properly index and make it useful. And for that, we designed the Firehose. And we were up against these issues, like issues of costs. We didn't want to run bulky nodes that take a lot of RAM and space and, dedicated SSDs, high performance stuff, and servers. No, that was complex and costly. And the goal was to get to the data inside. We didn't want to deal with these things. It was complex. Also, reliability. We wanted something more reliable, more, less moving parts, less risk of inconsistency when you have many of such nodes you need to query, and they're not all synced to the same place. And so we want also consistency across the ecosystem. If some people have their nodes with JSON RPC, you need to query them like crazy, billions, people tout billions of queries. But it makes it very cumbersome. Some other have WebSocket streams, not always reliable, or across reorganizations and things like that. And also, some built indexing frameworks, reinventing the wheel for their own particular stack. And so a lot of these introduced big costs, low reliability, and lack of consistent performance. So we wanted to do something simple. One of the core insights of Firehose is the use of flat files. Flat files paired with the streaming first engine. So we would get best of both history and real time. So flat files are the cheapest. I mean, it's ridiculous to be talking about flat files, I feel, but it's not all over the place. And they're cheaper than processes, programs running. They're easier to work with. There's nothing simpler and cheaper. So, we went to the ground level here in terms of computing resources. A small anecdote, those folks on the Graph today using the Firehose to feed their indexing system saw a reduction of cost of 90%. That's 90. Because they could stop querying huge bulky nodes and have data pushed to them instead. Much faster, lower latency, and much cheaper. So one thing is common from all blockchains is that they produce data that people want to use for, it's a database. So half of the equation of a database is reading the data. And with a good and open data format for every chain, it's sort of a unified, and we chose Google Protobuf definitions for the widest compatibility, we can conceive of the best data model for each chains. And that helps with simplicity, unifying of the stack. And with regards to latency, if Firehose equalizes all chains, and we chose fast instead of, sometimes unreliable. So all those chains get transformed when they're Firehose enabled into push first. They're pushing the data out. Lowest latency, the moment the transaction occurs, you get it. And regarding reliability, we address that by lowering the reliance on nodes and also making things simpler. If things are simpler, they're more reliable. You know, the optimization of object storage, you know, S3 and whatever, Google buckets, is the most optimized thing on earth, right? And you have so much tiers that you can have costs go low and put it in Iceland, I don't know what, you know. And on all that simplicity, oh yeah, there's one last thing, and one very important insight is that the whole stack was made blockchain aware with a cursor that allows for pristine reorganization navigation. So all these cases is really taken care of here. And all that lays the ground for massively parallelized operation, which we'll see now with Substreams. So Substreams is what I just said, massively parallelizable, general purpose transformation engine over firehose data, therefore any blockchain data beneath, right? And it works in batch mode for processing history and also back testing if you're running, I know, trading operations, and also real time with low latency. So there's no compromise. That level of the stack doesn't have compromise. We made it the both, you know, solve the, you see that? No. That's OpenAI gone berserk. He didn't understand. So once we have a reliable and fast source of data with Firehose, here's what we want to address. We've seen so many reinvention of the wheel. One of them is like the teams of each blockchain protocol roll out their own indexing technology. They all, how many wrote like a thing to write into PostgreSQL directly in their node? They all do that. But it's a lot of duplication and inconsistent behavior. And also, these are not Lego blocks. These are Lego brands, each not fitting with one another, right? With the holes not the same size. So that produces inconsistent experiences for folks making sense of that open data that blockchains produce. I don't like that, you know? So what we did, so it's another thing. Another place where, you know, we reinvent the wheel is that understanding of contracts. You want to understand contracts, so you start digging and going to that obscure land of data and try to decode it. And then multiple people do that. And you know, that's the layer I mean when I say the shared intelligence layer, understanding what's happening on chain. The problem is twofold, that either teams start digging into the smart contracts themselves, interpreting the data again and again, oftentimes with a lot of quality issues because they're not perfectly knowledgeable of the protocols because all the maths involved and whatnot, or they use providers that do that, like name a few of the lowest providers that give you, you know, intelligence about Uniswap v3 or whatever. But they capture that intelligence into their proprietary stack, and you can consume it in the way they provide it to you. So, you know, Subgraphs is one of the tech that captures that crowdsourced knowledge outside of proprietary stacks. You can use locally, and you can share it around. That's a nice abstraction, but it also constrains you to a certain model of consumption. And with Substreams, we want to solve that by bringing that intelligence layer lower down the stack so you can decide where you're going to dump that data and, you know, not have to rewrite it again. The right abstraction, we're going to get that. Problems also, performances. Performance is crazy in this space. Like the histories are constantly growing. Of course, history grows. And if you don't design for addressing that earlier on, you're getting technologies that are linear. And I remember that provider was down for 3 weeks. You know, 3 weeks being down in any company kills you. I don't know, people will, and they were reprocessing their chain linearly. That was such an absurd situation for me. I said, never on earth we want to tolerate that. I want all the systems to sync full networks in 30 minutes. Let's design for that. And that's what Substreams is. It allows you to parallelize operation, crunch data, reprocess. Firehose also, by the way, everything in that stack was designed for extremely high speed and iteration. Because one of the other issues is slow dev cycles. If you have a slow dev cycles, your product is dead. You can't iterate. Remember that build, measure, learn loop, huh? In startup, you need to learn as fast as possible. If you can't iterate, what do you learn? Like you try something, at 2 weeks you might see the result. That's crazy. So we wanted to solve for that too. You know, so what we did was this. You know, everywhere in technology, people start reinventing the wheel when they find just the right abstraction that gives them the power to do what they want without being in the way, having something they don't want in a way. So we worked hard to find the simplest and the best abstraction for maximum performance and composability. Flat files, streaming first, rich data models, and you know, a part of that abstraction is also the place in the stack to aggregate the knowledge of all these contracts. You know, if you put them in a downstream SQL store, you lose streaming ability. If you put that, like you stream it to Slack because your engine was made to send it to Slack, you lose, other components. So if we can put that shared knowledge earlier on in the stack, then we can reuse it in multiple fashions. And also, Firehose, Substreams, all these things are in the open, runnable by you locally, by some, whatever provider you want, and the Graph network with its pool of indexers over there that will run your loads, because for you. They'll offer you that service, but you're still free. Like, to achieve truly open data, that shared intelligence layer must not be locked into proprietary frameworks like Dune and Friends and things like that. But maybe the most appealing feature is performance. You can process large histories in minutes, splits the work, works in parallel, and then it also works in real time. So with the time you invest, to craft these things, you get all these benefits. There's no compromise. You can get the lowest latency on the market. You can imagine, tent poles that you interlock, right? When the blockchain produces something, poof, it pushes down to Substreams, Firehose, tuck. It's all a push fashion. And the nodes race together to get you the data as fast as possible. So there's nothing more that can be done in terms of latency there. It also has great introspection capabilities. Oftentimes you have people with quality issues. You take that provider. With Substreams, you can go directly into that place in the middle of the chain, analyze all the data bits before needing to reprocess and load your Postgres database yet another time again. So it is the first general purpose programmable indexing stack for blockchain data. Works across protocols and blockchains with unparalleled performance. So quick look at how that works in reality. This is that shared knowledge. You have someone, the author in red. He understands Uniswap, builds those blocks, and then you have the sushi guys, another team building intelligence about the sushi, and you merge them together. And the junction of all these things is clean, clear data models. Well distinct data, not request response, not complex node operations. And so you can have another guy coming down here, trader. He's going to take that collective knowledge and then fuse it for his own purpose, doing, some whatever, and feeding that into his trading operation, fusing with OpenSea trades and whatnot. But then where does that data go? This is all streaming real time and extremely fast historical reprocessing. So it puts us in a new problem. The last few years has seen in the world of data science a tremendous amount of new development, and there's a new database that crops up each week for all I know. So many tools, so many use cases. And that perhaps is not as much as a problem as an opportunity, because the number of new developers, we want new developers in this space, right? But as they come with those experience and knowledge and expectations. They want to use those powerful engines. And we want to make it as simple as possible to use them without sacrificing the composability and that shared intelligence layer. That's why it fits at the right place to leverage it maximally. And the solution to that is sync it everywhere. Substreams, the abstraction for knowledge, and then develop the tools that, I've seen so many protocols also write natively. That protocol will have a plugin for Kafka, that protocol will have a plugin for MongoDB and whatnot. But if you integrate as a layer one, the Firehose, you get all these crazy things once and for all with a community of people developing intelligence. And then that's a good value proposition for your folks, right? The first one was Subgraph with and Substreams today can power subgraphs and deploy them to the network. And so you have folks that are going to host that for you and benefit from the network effect of the graph there as an end-to-end solution. But we want to bring all these systems to the graph network and deploy processes so that other folks run them for you. But we keep that refined intelligence layer. So we're writing a boatload of things. Yeah, one example I had, the guy, he's an accountant, and he started writing a Substreams module to feed that into Google Sheets for all I care. And he was tired of doing copy-paste, from Etherscan. So now he has a bit of code that can understand the chain's transaction and poof, sync it over there. So talk about reuse. So we're really targeting any custom programming language, any data systems we can bring that, supports, for instance, protobuf gRPC, which is a wide array. Okay, now that we know all that, if you want to take part of that revolution of open data and shared intelligence, ask your preferred chain if they are Firehose enabled. And if not, ask them to work with us to transform them, to add that a thin layer so that they benefit from the rest and all its community. And then, if you manage a DApp or smart contract, encode your knowledge into Substreams modules. Make that intelligence available to for people consuming in any way, once and for all. And for all of you, I mean, keep an eye on the graph, because we're going to bring all these data services in the world to the graph network. Thank you all.